I've been asked a question today about transformations in the plane, and we're looking at transformations of a quartic first, of the form x to the 4, this one specifically. We're going to look at basically 3 successive transformations required to make this one, and then what they look like on the graph. And then we're going to do a very similar thing for the second one down here, which is a quadratic. So let's get started. Firstly, I can get myself out of the way. So we've got g of x is negative of x plus 2 to the 4 all over 3. So we can see, if we kind of unwrap the layers from the outside, we can see there's a minus sign out the front, and then everything that the minus sign applies to has been divided by 3, and then everything that's been divided by 3 there, inside we have x plus 2. So we're going to think about how we achieve each of those things and what they mean on the graph. Now I've used type maths here to write up some notes to kind of get us there. So here is the g of x function that we're trying to produce, and then here's the f of x that we're trying to alter to get it. So the first thing we can do is we can say a of x equals f of x plus 2. Okay, in other words, instead of taking f as a function of x, we're taking f as a function of a line that, so where we might think of f of x being a function of y of x, we're now doing a function of y of x plus 2. So that's the first thing that we're going to look at on the graph here. Now I've already got a bunch of stuff graphed. Let's get back to the basics. So if we had y equals x, now we're interested in what we get when we have y equals x plus 2. So if we just add 2 there, we can see it shifts to the left, right? So there's y equals x, and there's y equals x plus 2 shifted to the left. You could almost imagine that it's being shifted, let me put an a there so we can just kind of drag it around. When we go from, so here's 0, and then we go to 2. So you could imagine that it's being shifted up instead of to the left. That's another way that you can think of this, but I think shifting it to the left is the more useful for what we're going to try and do. So if we said y equals x plus 2, we'll get rid of a, and then we can say f of x equals x to the 4. So what we're going to do in order to shift that to the left is we're going to do f of y. All right, does this give us anything? Hold on. Let's say this is a of x. And so then we're going to do f of a of x. All right, so there we've shifted to the left using our straight line. Now, the next thing that we need to do is we need to squash it down. So we can say b of x is equal to x on 3. So again, we're taking this straight line, this squashed line. So by wrapping this in b of x, we're going to squash it down. So again, you can see that when we put the b of x around it, it's going to become kind of wider because all of the values have been squashed. There it is, wider. And then the last thing we need to do is we need to flip it upside down. So we can say c of x equals negative x. And so this is like that y equals x line, but flipped upside down. And so if we put c of x around here, we're going to flip our function upside down. So to get from there to there, we've applied a series of transformations, right? So everything's being done with reference to this y of x line. So have a look here. The first thing we're doing is we're shifting to the left. And shifting to the left is done using this a of x function, which is going to shift everything to the left. Then the next thing we need to do is we need to scrunch everything down. So where the a of x function shifted our y equals x to the left, the b of x function shifts our y equals x line by squashing it down. And so it does the same thing to the function that we're working with. And the third transformation we do is flipping it upside down. So this is c of x is like an upside down version of y equals x. And so it's going to give us an upside down version of the function we're interested in. So we get this one. And just for good measure, let's check. We know that g of x is equal to negative, and then we've got x plus 2 to the 4, and that's all over 3, and there we can see that is a perfect match. Goes right over the top of our composite function. So what we've looked at here is an answer to the question of how we can use 3 successive transformations of f of x to produce g of x, and we've looked at each of the graphs of the transformations every step of the way, and what the graphs of the transformations are themselves, which were all those variations on the y equals x straight line. Now, is that the only solution possible? Not really, not really. I mean, we could have swapped the order of our functions. And you can also use some much more complicated functions, you know, pointlessly complicated functions to achieve the same result. So let me show you, for example, if we swap the c, with the b, we still get the same thing, right? So swapping the order is also a valid solution. But similarly, instead of saying b equals x over 3, we could say b equals 3x over 9. And we're still going to get that same answer because 3x over 9 gives us the same output as x over 3. So we could also say b of x equals negative c of that thing, right? So the c is going to make the 3x over 9 negative, but then we negative it again and we still get the same thing. So this is needlessly complicated. But what I'm trying to do here is show you that we get the same function from different solutions. So that's that second part there. Is our solution the only correct answer? No, we've justified that by showing other correct answers. Now let's go on to question 7. So question 7 is very similar, but this time we're working with a quadratic. Now, what you'll see that I've put in the notes here is that when we have a quadratic, if there's a positive x squared, that means it's concave up. And the way I remember this is positive emotions, you smile. This is a concave up shape. Negative emotions, you frown. That's a concave down shape, right? So in this case, we see we have a negative x squared. So we're going to have a frowny shaped parabola. All right, what else is going to be done to it? Well, it's going to be shifted, you know, this 5 means there's some vertical shift going on, and this negative 4x here probably means there's some kind of side-to-side action happening. Now, there are a couple things we can do. We can factorize it. That will tell us the x-intercepts. But what I'm actually going to do is I'm going to complete the square first. And completing the square is going to allow us to really easily see what transformations side to side and up to down have been done. So I'm going to work through this pretty quickly. The first thing that I want to do is I want to change the order in which this is, and that's just a personal preference. It doesn't change the working at all. The next thing I'm going to do is I'm just going to put all of this inside some brackets because I like working with positive quadratics more than negative quadratics. Now what I'm going to do, completing the square, we're going to look at what is half of the linear term, the x term. And so we're going to split that plus 4x into plus 2x, and I'm going to add a 4 here and subtract a 4. I'm not going to explain in much detail why I've done that. If you don't know what I'm doing, then what you need to look up is a technique called completing the square. This is basically allowing me to take all of these terms here and factorize them into a single squared term. And then that minus 4 minus 5 becomes minus 9. So I can get rid of that outer set of brackets now. We have a difference of 2 squares, which basically means that we're going to have this thing, and we're going to have the same thing, but without the negative. So let's simplify this a little bit. That's going to be a 7. Whoops, no, not quite. I forgot to square root the 9. That should be a 3. So that's going to be a 5. And then this is going to be negative x minus 2, and minus 2 plus 9 is actually going to be plus 7. So this tells us that we have our roots at x equals, sorry, minus 2 plus 3. How did I get 7 out of that? Minus 2 plus 3 is 1. So our roots are going to be when x equals to 1 and when x equals to -5. This is going to be where we're going to cross the x-axis. So x equals -5 and x equals 1. That should be that. Okay, so let's chuck this into the graphing calculator and see what we can come up with. Boom, 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 boom. All right, let's start with y equals x. So this is our straight line. And if you recall from the last example, all of our transformations were based on straight lines. What we need to do to get to this form here, before we use difference of two squares to factorize it, but after we completed the square, we get that it's been shifted to the left by 2. So let's say a of x equals x plus 2, right? We saw that in the last one. We can also see that it's been made negative. So we can say b of x equals -x. And the last thing we can see is that we've added 9 onto the end of it, which amounts to shifting it up by 9. So we can say c of x equals x plus 9. So these are all the different transformations that we're going to use. First, we're going to shift it to the left, then we're going to flip it upside down, and then we're going to move it up by 9. So what we want to do is we want to take, if f of x equals x squared, we want to do, let's say, c of b of f of a of x. And so what we get is something with roots at 1 and -5 that's been shifted to the left by 4 and shifted up by 9. Is that left by 4? No, left by 2 and up by 9. So we get -2, 9. And that's exactly what we saw here, shifted to the left by 2 and shifted up by 9. We also spoke earlier about how it was going to be a frowning parabola shape, a negative motion being expressed there. And then we looked at where the roots were going to be. So all of those important things, the axis of symmetry, which is the x value of the vertex, the roots, all of that we worked out. We didn't work out the y-intercept, but the y-intercept can actually be read off of this. When x is 0, y is just going to be equal to 5. Okay, so it took me a long time to explain all that. I hope that that makes sense. If you have any other questions, just ask me. And anyone who's coming across this on YouTube, if you've got any questions, I don't know, drop something in the comments and hopefully I'll see it and I'll be able to make another video answering your questions too.